Chances are you've never seen one of these up close. A single palm fruit nestled in its huge thorny bunch. It grows on towering palm trees, often thousands of miles from where you live. And yet, what's locked inside this small reddish fruit is almost certainly in your home right now. It might be in the chocolate in your cupboard, the shampoo in your shower, or even the bread for your sandwich. It's one of the most versatile and widely used ingredients on the planet. So how does this humble fruit get from a sun-drenched plantation into thousands of products on supermarket shelves all over the world? The answer is a story of incredible scale and powerful industrial engineering. The transformation happens inside colossal factories like this one, mega mills that operate around the clock, processing millions of these fruits every single day. These aren't just buildings, they're vast, synchronized systems of steel and steam designed for one single purpose: to unlock the golden oil held within. Today, we're going inside. We'll follow the palm fruit's complete journey, from the moment it's harvested to the final, purified oil getting pumped into giant tankers. We're about to witness the immense machinery and sheer volume that define a modern mega factory. Chapter 1. The source: harvesting on an industrial scale. The story of palm oil doesn't start in the factory, but out in the sprawling green expanse of a plantation. Here, tens of thousands of oil palm trees, Ilex guineensis, stand in neat rows, stretching as far as the eye can see. The oil palm is a marvel of productivity. After starting to bear fruit at around 3 to 4 years old, it has an economic lifespan of about 25 years, producing fruit year-round. This efficiency is why palm oil is so dominant globally. It yields far more oil per hectare than any other vegetable oil crop, like soy or sunflower. But this relentless production creates a monumental logistical challenge. The harvest never stops. Every 10 to 14 days, a mature tree is ready to be harvested again. This constant cycle requires a dedicated and highly skilled workforce. Harvesting is intense, physical labor. The fruit grows in dense, heavy clusters called fresh fruit bunches, FFBs. A single bunch can weigh over 20 kilograms, sometimes up to 50, and is covered in sharp, 2-inch thorns that demand careful handling. Harvesters move through the plantation, their eyes trained to spot the signs of a ripe bunch. The first clue is color. The fruit changes from a deep blackish purple to a vibrant red-orange. An experienced harvester also looks for loose fruitlets at the base of the tree. If a few have fallen, it's a sign the bunch is at peak ripeness, holding the maximum amount of oil. For shorter trees, the work is done with a sharp chisel. But for older, taller palms that can reach 20 meters, the tool of choice is a long, curved blade called a sickle, mounted on a pole. With practiced precision, the harvester positions the blade at the bunch's thick stem and, with a powerful pull, severs it from the tree, sending the heavy cluster crashing to the ground. It's a job that combines strength, skill, and an intimate knowledge of the tree. On an industrial scale, we're talking about thousands upon thousands of these bunches being harvested daily. As soon as the bunches hit the ground, another team moves in. Workers gather the heavy clusters, using a spike to help lift them and load them into carts or trucks. In some highly mechanized operations, front loaders scoop up the bunches and load them directly. It's a race to get this massive quantity of fruit out of the field and on its way to the factory. And the clock is already ticking. Chapter 2. The race against time. Transportation. The moment a fruit bunch is cut from the tree, it begins a race against an invisible enemy: enzymatic degradation. Inside the fruit's flesh, enzymes like lipase are immediately activated. If left unchecked, they begin to break down the precious oil into free fatty acids, FFAs. High FFA levels cause the oil to go rancid and dramatically lower its quality and value. To prevent this and guarantee a high-quality product, The fresh fruit bunches must be transported and processed at the mill within a critical 24 to 48-hour window. This tight deadline turns the entire operation into a fast-paced, highly coordinated effort. Trucks, piled high with bright red fruit, converge from all corners of the plantation, all heading to one destination, the mega mill. They arrive one after another, queuing up to be weighed on a massive weighbridge. This data is crucial for tracking the factory's intake and calculating its efficiency. Once weighed, the trucks proceed to the reception bay to unload with brutal efficiency. Many trucks use hydraulic tippers to dump their entire multi-ton load in seconds. The result is a literal mountain of fresh fruit, a vibrant red and orange mound that can fill an area the size of a building. The air is thick with the sweet, earthy smell of the palm fruit. Standing before this colossal pile, you truly grasp the mega in mega factory. This yard is the buffer that ensures the factory has a continuous supply of raw material. But the fruit doesn't sit for long. Huge bucket loaders scoop up tons of fruit bunches at a time and dump them into steep hoppers, the gateway to the factory's automated interior. From here, the bunches fall onto a series of heavy-duty conveyor belts. This is the last time they're handled in bulk. From now on, their journey will be almost entirely mechanized, a continuous flow managed by machines through a maze of steel corridors. The race against time continues, now heading toward the first, most critical stage of transformation. Sterilization. Chapter 3. The Crucible. Sterilization. The conveyor journey leads the fruit bunches to the first major stop inside the mill. The sterilizers. They're loaded into enormous steel cages, which are then pushed into long, horizontal cylinders that are essentially giant, industrial-scale pressure cookers. Once the heavy-duty doors are sealed, a crucible of high-pressure, superheated steam begins its work. For the next 60 to 90 minutes, the fruit is subjected to intense conditions. High-pressure steam is blasted in, raising the temperature to around 140 degrees Celsius and the pressure to about 3 bars. This wet heat treatment achieves several crucial things at once. First, it's a sanitation process, killing any bacteria and fungi on the fruit. Most importantly, for oil quality, the steam completely deactivates the lipase enzymes that cause rancidity. Halting this activity right at the start is the single most important step in controlling the final quality of the crude palm oil. The steam also profoundly softens the fruit, breaking down the binding material, holding the individual fruitlets to the bunch. This makes it much easier to separate them in the next step. Finally, the heat and pressure start rupturing the oil-bearing cells within the fruit's flesh, a sort of pre-digestion that primes the fruit for maximum oil extraction. After the cycle is complete, the steam pressure is released with a deafening roar and the cages of cooked, steaming bunches are pulled out. Their vibrant red color has deepened and they are hot, soft, and dripping. The bunches are no longer just fruit. They are now prepared raw material, ready for mechanical disassembly. The fight against spoilage has been won. Chapter 4. The Separation, Threshing. The hot, sterilized bunches continue their conveyor journey to the next imposing machine, the thresher. The goal here is simple: to strip the now loosened palm fruits from the stalks they grew on. The most common thresher is a massive, rotating drum tilted at a slight angle. As the sterilized bunches are fed into the high end, the drum spins, tumbling them over and over. Because sterilization loosened the fruit perfectly, each impact knocks more and more of the small, soft fruitlets free. They are small enough to fall through the gaps in the drum's walls, where a conveyor below catches the cascade and carries them away to the next stage. Meanwhile, the large, fibrous, and now empty bunch stalks are tumbled down the length of the angled thresher and emerge from the other end completely bare. But in a modern mega factory, they are not waste. These empty fruit bunches, or EFBs, are a valuable byproduct. Many are transported back to the plantation and used as a natural fertilizer, returning nutrients to the soil. Alternatively, these fibrous EFBs are taken to the factory's boiler house. They are burned as a renewable fuel to produce the superheated steam that powers the entire factory, from the sterilizers to the electricity-generating turbines. This creates a closed-loop system where a waste product from one stage becomes the fuel for another, a hallmark of an efficient operation. With the fruit now separated, our focus returns to the stream of individual fruitlets now being conveyed toward the heart of the extraction process. Chapter 5. The mash and the squeeze, digestion and pressing. The river of warm, soft palm fruits is now on its way to the main event. First, they tumble into the digester, a large steam-heated vessel with rotating arms that churn and mash the fruit. Digestion completes the work started by the sterilizer. The mechanical mashing, combined with continued high heat, thoroughly ruptures the oil-bearing cells in the fruit's flesh, or mesocarp. The fruit is transformed from individual spheres into a hot, thick, oily mash, primed to release its contents. From the digester, this hot pulp is channeled directly into the screw presses. This is where the oil is finally liberated. A screw press is a marvel of mechanical power, consisting of a large auger-like screw rotating within a perforated cage. As the screw turns, it churns the mash forward while subjecting it to immense and continuously increasing pressure. This tremendous pressure squeezes the oily pulp with incredible force, forcing the liquid crude palm oil out through the perforations in the cage. This raw, unfiltered oil is a brilliant, fiery red-orange, a color that comes from its high concentration of beta-carotene, the same antioxidant that gives carrots their color. This liquid, known as crude palm oil, CPO, is the primary product the factory is after. What's left behind is a solid press cake, a fibrous mix containing the hard-shelled nuts. And you guessed it, this isn't waste either. The fiber is separated and sent to the boiler house as biofuel. The nuts, however, are a valuable commodity in their own right. They are sent to a different part of the factory to be cracked open, releasing the inner kernel. This palm kernel will be pressed to produce a completely different product: palm kernel oil, which is common in cosmetics and confectionery. This zero-waste approach is fundamental to the economics of a modern palm oil factory. Chapter 6. The purification, clarification, and filtration. The hot red crude palm oil gushing from the presses is still a messy cocktail of oil, water, and solids. Before it can be stored, it needs to be cleaned up in a process called clarification. First, the crude oil is passed over a vibrating screen to filter out the largest bits of fiber. From there, it flows into enormous clarification tanks. Inside, the oil is kept hot, around 90 degrees IC, to let gravity do its work. Over several hours, the mixture slowly settles into 3 layers. The lightest component, the purified oil, rises to the top. A layer of water sits below it, and the heaviest sludge collects at the bottom. The top layer of oil is carefully skimmed off. While much purer, it still contains residual water and fine solids. To get rid of these, the oil is sent through a centrifuge, which spins at incredibly high speed, using centrifugal force to separate the denser water and solids from the lighter oil. After the centrifuge, the oil goes to a vacuum dryer to remove the last traces of moisture. By heating the oil under a vacuum, the boiling point of water is lowered, allowing the factory to boil off any remaining water without damaging the oil. The result of all this is clean, bright, crude palm oil, CPO, ready for storage. The sludgy wastewater from the bottom of the tanks, known as palm oil mill effluent or POME, presents a major environmental challenge. Modern mills invest heavily in wastewater treatment systems, typically large ponds where the perm is broken down biologically over time before the water can be safely discharged or used for irrigation. Chapter 7. The final polish, refining. The secret step. The journey so far has produced crude palm oil, but for most food and cosmetic applications, this red, flavorful oil isn't what manufacturers want. They need a neutral, odorless, and light-colored oil. To get that, the CPO must undergo one final, complex transformation: refining. This is a world of chemical and physical engineering that is rarely shown to the public. Refining typically involves several key stages. First is degumming, where compounds like phospholipids are removed by mixing the oil with water or acid, causing them to precipitate out. Next is the most visually dramatic step: bleaching. The oil is heated and treated with a natural adsorbent material like bentonite clay, also known as bleaching earth. This clay binds to the color pigments, primarily the red-orange beta-carotenes. When the clay is filtered out, it takes the color with it, leaving a pale, light yellow oil. The oil is now clean and light, but still has a distinct odor and taste. The next stage, deodorization, solves this by heating the oil to high temperatures under a near-perfect vacuum and passing live steam through it. This process strips away any remaining free fatty acids and volatile compounds that cause unwanted odors and flavors. The result is RBD palm oil, refined, bleached, and deodorized. But there's often one more crucial step: fractionation. Palm oil is naturally semi-solid at room temperature. Fractionation separates this oil into its liquid and solid parts. The oil is slowly cooled in huge crystallizers, causing the fats with higher melting points to solidify. This slurry is then passed through a membrane filter press, separating it into two distinct fractions. The liquid portion is palm olein, the clear cooking oil you'd find on a supermarket shelf. The solid portion is palm stearin, a hard fat used to make margarine, shortening, and soaps. Chapter 8. Ready for the world, quality control and packaging. After enduring this gauntlet of processing, the oil is almost ready. But first, it must pass one final gatekeeper: the quality control lab. Throughout the entire production chain, samples are constantly analyzed, but this final check is the most critical. Technicians run a battery of tests, using sophisticated equipment to verify purity, measure free fatty acid, FFA content, and check for moisture, color, and stability. Only when the lab gives the green light can the product move on. The scale of distribution is as massive as the production. The refined oil is pumped into high-speed automated bottling lines for consumer markets. For industrial clients, it might be packed into large drums or containers. A huge proportion of the factory's output, however, is destined for bulk transport. The oil is pumped directly into road tankers or specialized rail cars. For the international market, it's often pumped into colossal tanks at a nearby port, ready to be loaded onto ocean-going ships that will carry tens of thousands of tons of palm oil to markets across the globe. So we've witnessed an incredible transformation. Journey that began with a single fruit in a tropical plantation raced against the clock to a factory and endured a gauntlet of mechanical and thermal power. It was sterilized, stripped, crushed, clarified, and polished to perfection in the secretive world of the refinery, bleached, deodorized, and even fractionated into different products. From a humble fruit to a global commodity, the process is a symphony of industrial might, designed for relentless, 24/7 efficiency. The next time you see vegetable oil in the ingredients list, you'll know the immense and complex journey that might be behind it. A journey of transformation on a truly mega scale. If you were amazed by this incredible process, give this video a like, share it with a friend, and subscribe for more deep dives into the world's most impressive mega factories.